All right, so today we're going to be doing 14.2, which is the addition rule, okay? So the probability of an event, you can just get it after we're done with this. It's calc. You're on the bottom. So the probability of an event is expressed like so. You guys paying attention? Okay. All right. So to find the probability of an event, you always want to have the outcomes of the event over the outcomes in the sample space. So I'll explain briefly what that means in a way that you probably understand a little better. So let's say you have a bowl of marbles, okay, 4 marbles. You have blue, green, red, and yellow, okay? And I said, what's the probability of pulling the blue marble? What would you tell me?
25 out of 4.
1 out of 4, or 25%, correct, or 0.25. That's the outcomes that you want over the sample space. The number of possibilities is what the sample space is. So this looks more complicated than it actually is. You all have a pretty general understanding of that probably from middle school. Probabilities always must be between 0 and 1. If you're talking about probabilities as a decimal, as a percent, they're always between 0% and 100%. So a probability of 0, if we had that same bowl of marbles, what would be the probability of pulling a black marble? 0. You can't pull a marble that doesn't exist, right? If we had a bowl of just red marbles, what would be the probability of pulling a red marble? 100%, or 1 in terms of as a decimal and not a fraction or percentage. Now, or probabilities. That means that when we are okay with an or, something happening or this thing happening, we have a better chance, so we're going to add them together. What we have to always subtract away is the probability of those two things happening simultaneously. So let me explain an example to hopefully help you understand this a little bit better. Let's say you had a deck of cards, okay? If you're not familiar with the deck of cards, we're going to talk about it in a second, but a deck of cards in general has 52 cards, 13 of each suit, okay? And each suit has ace, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, okay? So let's say you are okay with pulling, what's the probability of pulling a diamond? 13 out of 52, because there's 13 of each suit, okay? So 13 out of 52 is the chance of pulling a diamond card, okay? What is the probability of pulling a queen out of the deck? 4 out of 52. We've counted those two things. You're okay with pulling either a diamond or a queen. But there's a problem. If we add those two together, that gives us some number, but is there a queen of diamonds in the deck? So what you've done is you've counted the queen of diamonds when you did this first probability. Didn't you count it again in this one? That's called double counting. That's where the subtraction comes in. You have to subtract away the thing happening simultaneously. So we'd have to subtract away 1 out of 56 or 52 because that would be the thing happening at the same time. Okay, so that's where that comes from, and we'll get some practice with that as well. But I just want to give you a general rundown of why there's a subtraction in there. Okay. So consider rolling a dodecahedral die, which is a 12-face die, just like a dodecagon in geometry, where it's numbered 1 through 12. So when the die is rolled, how many total possible results could occur? 12 results. Of those results, how many ways can an even number be rolled? So not the probability of an even number, but what are the even possibilities? A 2, a 4, 6, 8, 10, or 12, which is 6 different times that could happen, correct? Everybody see why those are all even rolls that you could get? All right. And what is the probability of rolling an even roll? 6 out of 12, which is the same thing as 1/2, which is the same thing as 0.5, which is the same thing as 50%. So those are all the ways in which probability can be presented, fraction, decimal, or percentage. Yes?
If it says probability, do we just put it in form?
I will let you know what format I want every single time on a test, something like that. What is the probability of rolling a number greater than 8? So let's just think, what numbers on this die are greater than 8? 9, 10, 11, or 12. So the chance is 4 out of 12, which reduces to 1/3, aka 33.3 repeating. Okay. So does anyone have any questions about that? Do you understand why the 8 is not included? because it's strictly greater than, not greater than or equal to. All right. So sometimes with these types of probability problems, we use a Venn diagram to help us get a visualization. Now, I might not always provide the Venn diagram for you, but you can always feel free to draw your own to help you get a better visual. I like to do it because I just am a visual learner and a visual person, but if you can do it without, that's fine too. But we're going to do one together. So, a veterinarian surveys 25 patrons. He discovers that 14 have dogs, 10 have cats, and 5 have fish. 4 have cats and dogs, 3 have dogs and fish, and 1 has a cat and a fish, and no one has all 3 kinds of pets. So step 1, whenever you're doing one of these, you always want to work inside out. That's really, really important. So from the very inside, what's going to go here?
Nothing.
0. Why is this one 0?
No pets.
No one has all 3. So nobody's going to be in that triple overlap. Okay. Now let's say I make this dogs. I would make yours the same as mine because it's easier to follow along, of course. Cats and fish. Now here is going to go the people who have dogs and fish, dogs and cats, cats and fish. So the first one says, remember we're working inside out, so we got to do these sections first. 4 have dogs and cats. So where am I going to put that?
The top middle.
Yep, middle. 3 have dogs and fish. Where's that going to go?
Bottom left.
Yep. And lastly, 1 has a cat and a fish. Good. Now, what you're going to notice is how many numbers are already accounted for in the dog section right now? 7. So keep that in mind. Now we're going to work our way out. So he discovers that 14 have dogs. We've already counted 7 of the dogs, correct? So how many more do we need to go here? 7. That's why it's important you work inside out, or you're not going to have the right numbers. 10 have cats. How many cats have we already accounted for?
5.
So what's going to go here? 5. And 5 have fish. How many fish have we already accounted for?
4.
So what's going to go here?
1.
Good. Now, keep in mind, he surveyed 25 patrons. So, now of course, you're not going to go to a veterinarian if you don't have a pet. But are these the only kind of pets people can have? No. So he only surveyed probably the top most common pets. But keep in mind, this number might not add up to 25 because there might be people who didn't have any of these types of pets. So here's what we have to do. We're going to take 25 and subtract away each of these numbers, okay? So that's going to give us anybody who's on the outer side of the sample space. And it should give you, 21 people are in the circle, so how many are going to be outside? 4. So those 4 people, of course, are just people who have pets that are not listed here. Does that make sense to everybody? Okay. So, what is the probability that somebody has only a dog?
7 divided by 20.
Good. 7 out of 25 of the people surveyed, right? What is the probability of having only a fish? Good. What is the probability of having only a cat?
1/5.
Yep. What is the probability of strictly having a dog and a cat?
4.
4 out of 25. What is the probability that you have a cat and a fish?
1 out of 25.
Good. Probability you have a dog and a fish?
3 out of 25.
Good. What about people who have a dog or a cat? So yeah, for dog or cat, you're going to add up all of the people in the dog and all the people in the cat. So 7 plus 3 is 10, plus 4 is 14, 14 plus 5 is 19, plus, no, I did something wrong. That's going to be 14 plus 5, 20. Yeah, it's 20. I was right. So dog or cat means you're okay, you're counting anybody who has at least a dog or cat. So you count everybody who's in any of those circles. Does everyone understand that? Okay. So I was doing it right. I was just guessing myself. So cat or fish, that's everybody in any of these circles. So 4 plus 5 is 9. 9 plus 1 is 10. 10 plus 3 is 13. Plus 1 is 14. So what about somebody not having a dog, cat, or fish? 4 out of 25. And what about somebody having a dog, cat, and a fish?
21.
0. That's for people who have all 3, which nobody does in this case. Make sense? Okay. Yes.
Will we need to like simplify these fractions?
I will always specify to you guys on a test if I want it as a simplified fraction, as a decimal, or a percentage. Okay. And if it needs to be rounded, I will tell you what to round to. Okay. So, in a survey of 743 teenagers at the Pew Research Center in 2018, 381 of those surveyed used Facebook, 532 used Instagram, and 310 used both. So this is the same kind of scenario, but you're going to see that there's not a Venn diagram provided for you. I know you don't have a lot of room on there. You don't have to draw one, but I'm going to draw one just so you can see a visual as you learn it, okay, your way through. But you don't necessarily need one. You can do it without. So I'm going to just quickly draw a Venn diagram real quick, just so you can see where the visuals of everything is coming from, okay? So it's not necessary, but it does sometimes help. So this first one is going to be Facebook. The second one is going to be Instagram, okay? So first thing we always want to do is count the boths. So where am I going to put the 310? The middle. Good. Now, of those surveyed, 381 used Facebook. So how can I figure out what goes here?
Oh,
Subtract. So 381 minus 310. That will give me 71 here. Now we know that 532 use Instagram, so how could we figure out what goes here? Subtract. 222. And then lastly, is it guaranteed when we survey them that they use either one? No. So what we have to do is we have to take the total number of surveyed people and subtract away all 3 of these numbers to get anybody who wasn't accounted for in the survey in any of these circles, right? So 743 minus 71 minus 310 minus 222. That'll give you 140. So what that means is 140 people surveyed didn't use either Facebook nor Instagram, okay? So what is the probability that a randomly selected teenager does not use Facebook? So if they don't use Facebook, we're going to exclude everybody in this section, correct? So the easiest way to figure that out is going to be to add up the people who use strictly Instagram and the people who what? Don't use any. And that's going to be all over, bless you, the total number of students.
Wait, how'd you get to 22?
That's everybody who uses Instagram but not Facebook, because remember we're excluding everybody who uses Facebook. I'm going to leave them as fractions, but you can divide them to get decimals too. What is the probability that a randomly selected teenager uses Facebook but does not use Instagram? So how many people here use Facebook but not Instagram? 71. Okay. What is the probability that a randomly selected teenager uses Facebook or Instagram? So we're counting everybody who uses at least one of them. So 71 plus 310 plus 222 all over the total. What's another way you could have gotten that number?
Subtracting 140.
Yep, subtract the 140. Make sense? And then lastly, what is the probability that a randomly selected teenager does not use either? How many do we have of those?
140.
140. All right, does anyone have any questions about the probability we did here? Yes.
How'd you find the 71?
To find 71, I take the total number of people who use Facebook, which is 381, and I subtract away the overlap.
Okay.
Okay. Any other questions? All right, we're going to move on. So I gave you this visual. It's not necessarily necessary, but I'm not sure how familiar all of you are with Dexa cards. it is going to be something you do want to learn as you go into probability, especially for anybody going into prob and stat next year. You really do want to know these because this is like a big probability stat topic that they use. So I'll just give you the general rundown. A deck of standard cards will have 52 cards. Of those 52 cards, there's going to be 13 of each suit. Okay, there's 4 suits. 13 times 4 is 52. So you have spades, you have clubs, spades, hearts, and diamonds. Okay, and each of those are going to have 13. Of each of those 13, there's going to be what we call 3 face cards. Those are the jack, queen, and king because they literally have somebody's face on them. Okay, that's how you can remember. So when we're talking about probability of these, this is what I'm going to use. So you can use this as a reference if needed. All right. So suppose a card is randomly selected. What is the probability of drawing a face card? So how many face cards are there total? Out of the total, which is 52. Now keep in mind, if this was a multiple choice, I'd probably have reduced this fraction, so just be aware of that. Suppose a card is randomly selected. What is the probability of drawing a red face card? So 6 out of 52, because those are the number of face cards that also are red, which are the hearts and the diamonds. And then lastly, suppose a card is randomly selected. What is the probability that the card is red or a face card? So when you see these, so when you guys see these OR problems, you can probably also like figure it out right off the bat, but I'm going to show you like the proper way to calculate it. So when you see OR, that means you're going to have to set up a few different fractions. So you're going to find the probability it's red first. So how many reds are there total? 26 out of 52. Plus, how many are face cards total? Now here's the problem. Are there any red face cards?
Yes.
So we have to subtract those away because we double counted them. So 6 of those are red face cards, so I have to subtract those away. So I know sometimes you guys can probably like figure it out without doing the math, but they do get more complex, so I just want to show you the proper strategy. So these are ones that are just red. These are face. And these are when both are happening simultaneously. Okay, so you have to subtract them away because you double counted them. So that's going to give me, I think, 32 over 52. Now keep in mind too, if you're okay with getting a red or a face card, does that increase your odds? Mm-hmm. Yeah, because if you're okay with something or the other, you're going to have more possibilities, correct? Does that make sense to everybody how OR works? OR is always addition. OR is addition. Probability 101. OR, addition. Make sense? Subtract away your double counts. Any questions about that? All right, I'm going to hand out your homework.